Okay, so there's always some craziness that we have to talk about when it comes to physiology, and so we had said that yeah, hemoglobin is carried by carries oxygen and it releases it as CO2 builds up, and all of that makes easy sense, and you think okay, I previously mentioned that most of CO2 is carried dissolved in the blood plasma. There is a small amount of it that does bind to a different binding site on hemoglobin. I think it's about 15% of it, but the vast majority of it is dissolved in the blood plasma. But it's complicated. So let me show you what happens. So what happens is CO2 is mostly carried as bicarbonate ion dissolved in the blood plasma. Now, if you remember again, going back to A&P1, remember we had said that CO2 in it combines with water to form carbonic acid, which dissociates into a bicarbonate ion and a hydrogen ion, the hydrogen ion without an electron. Well, this doesn't happen in the blood plasma. It happens in the cytoplasm of the red blood cell. So what happens is the CO2 diffuses into the circulatory system from the cell where you've had cellular respiration going on, and you create this waste CO2 that we're having to get rid of. So the CO2 diffuses into the circulatory system, then into a red blood cell. And in the red blood cell cytoplasm, this is where the CO2 and the water combine to form the carbonic acid, and then the carbonic acid dissociates into the bicarbonate ion plus a hydrogen ion. So that's in the red blood cell. But we said CO2 is mostly carried as a bicarbonate ion in the blood plasma. Well, so what has to happen is it diffuses out of the red blood cell. So we have what we call the chloride shift. And what this is if you take a negative ion out, you have to replace it with something else. So the bicarbonate ion leaves the red blood cell and is dissolved in the blood plasma. And when it does that, a chloride ion, another negative ion, is going to replace it in the red blood cell. Okay, so now we've got the bicarbonate ion in circulation. It makes its way to the capillaries in the lungs. What does it do? Goes back into a red blood cell, combines with a hydrogen ion, forms carbonic acid, and then it goes back and becomes water and CO2 and diffuses out. Complicated, right? But that's the way it works.